Well, here we go. Let's look at 11.3. We are working on polar coordinates day 1. We are going to learn how to plot points, do some conversions, and then work with equations in polar as well as rectangular XY mode. So on with the show. Is there anything down below? No. Okay. So let's just work on plotting points. We have 4 points here to plot. Remember that polar comes in the ordered pair of r followed by theta, r being the length of the radius radiating out from the origin, the 0, and theta being the amount of angle turn from the positive x-axis, which acts as our polar axis. So let's see, the first one we've got 2 and pi over 3. I tend to spot my angle first, so I will probably rise up to pi over 3, and then I'm stepping a positive 2 movement. So on the pi over 3 line, I'm going 1, 2, and my location there for point A will be there in quadrant 1. All right, 3, 5 pi over 6. So I will find 5 pi over 6, and I want to be out 3 units, 1, 2, 3. When I'm on that line that makes the 5 pi over 6, the side that contains that other ray for the angle is the positive quantity. Next, for C, we want -2, so we'll talk about what a negative does, but first let's find 5 pi over 4. 5 pi over 4 will radiate all the way around here, and this will be the positive branch of our plotting. I want -2. If I plotted here, that's actually +2. So I bounce over to the other side. So if I bounce over 1, 2, I'm going to be locating, I guess it's point C right there. Okay, that negative causes us to bounce back across. Here I have 1 negative pi over 6. Negative pi over 6 will be here. Notice that this is subdivided into 12 equal parts, so to get a sixth, we got to go 2 sections. Negative pi over 6, and we want to step out 1 unit, which would be there. Had this been -1, then I would have bounced across to right there. So this is D. That's plotting points. Next, we're going to talk about some conversions and things that are good to know for conversions. Well, let's first just draw in the basic triangle that we all started with when we were in pre-calc. We talked about theta being situated at the origin. The positive x-axis was always acting as our baseline that we radiated up from. This distance for the hypotenuse was given r. This is up a value of y units, and it is moved across x units so that we get distance here and the distance there. So we can use this as a little bit of our foundation for coming in to define cosine. And cosine, well, cosine I know is cos, so it's adjacent over hypotenuse. And according to my picture, that would be an x over r. Sine is so that is opposite over hypotenuse. And in that case, we got y over r. Tangent is TOA, so we got opposite over adjacent, and opposite is y, x is adjacent, y over x, because remember, everything was based off of our theta being in that first quadrant. So from this, I could solve for cosine, couldn't I? And that would mean that I would multiply both sides by r, and I would get that x is equal to r times cosine x. Y is equal to r sine x. And tangent of theta, there's really nothing we're going to change on that. Let's just keep in mind that it has a relationship between y and x, which can be helpful. R squared. Well, r squared, this is a right triangle, so I can use Pythagorean theorem to come up with x squared plus y squared equals r squared. Or you could even think of the equation of a circle centered at 0, 0, right? With a radius length of r. This one here, let's knock down to just r, and we're going to go with the positive r being x squared, y squared, quantity square rooted. So those are just some conversions that are nice to know. And here we go. Let's convert the polar coordinates to rectangular coordinates. What do polar coordinates represent? Well, they represent an r and a theta, don't they? I'm not getting it to right there. So this is my r, this is my theta. I want to convert it into an x and a y. How can I do that? Well, I know that x is r cosine and y is r sine theta. So I'm going to use those two conversions. So I'm going to let x equal, my r value is 4 and the cosine of 5 pi over 6. 5 pi over 6, well, that swings around to right there. It's the cosine value. That's a negative then since it's quadrant 2. So this will be x equals 4 times negative square root 3 over 2. Yes, we will want to know our unit circle. There we go. X equals negative 2 square root 3. Let's go find y. Y is r sine theta. Well, let's grab our r, which is 4, and the sine of 5 pi over 6. That's a 4 times sine. Well, sine is positive in quadrant 2, so it's 4 times a half, and I get a y value of 2. So corresponding in rectangular format is the negative 2 root 3, 2 location. Would place it the same as that polar. Convert the rectangular for each polar back to polar. So I know what I want to do. I want to take xy and swing it back into, whoops, I was going to write r, swing it back into r theta. How do I calculate r? Well, I know that r is equal to the square root of x squared plus y squared. Okay, let's start there. R is equal to square root 3 squared, so 3 plus 1. R is 2. Now, that's a positive 2, and I got to make sure I land in the right quadrant. So just for a moment, I'm going to think this is quadrant positive x, negative y. This sounds like a quadrant 4 value to me. Let's see. We want to get to theta. I have x and y, don't I? So let's use tan theta. We know is x over y. Oh, okay. So now we can substitute in. Tan theta equals x is square root 3. Y is negative 1. I really just want theta, so I'm going to do the tan inverse of negative root 3. All right, now we got to think about those. Those are ones that just don't always stick with me, but I believe we would find square root 3 to be right there. And that means that, where am I at? A pi over 3 quantity? Or did I? Oh, you guys probably caught this. Let's back up a little bit because this isn't true, is it? Switcheroozy. All right, I should have y on top, opposite over adjacent. That makes it y over x. And this would be 1 over square root 3. Then 1 was negative. So I want inverse of negative 1 over root 3. You know what? Let's rationalize that because you might recognize that better. Square root 3 over 3. And that is this location here, which is a pi over 6 quantity, isn't it? I almost went with the pi over 3 one. And we want to be in quadrant 4. So I've got a couple ways of naming this. I could name it as negative pi over 6 with a positive r. That would keep it in quadrant 4. I could also name it as a 2. I was just looking at this. They say they want the theta expressed as a positive. Well, then that's going to force me to wrap around in this direction. So that's going to be 11 pi over 6, isn't it? Which would be the correct ordered pair then. I'm going to cross out that one since it said I had to have my theta expressed as a positive. All right, -3, 3. You might even be able to figure this one out. Let's just locate it. If it's at -3, 3, wouldn't it have to be a 45-degree angle there? So wouldn't this have to be 3 pi over 4? I do believe so. It's just the r that we'll have to get. Okay, so let's go r equals square root of -3 squared plus +3 squared. R equals 9 plus 9 root 18. R equals, do we want to, yeah, sure, 3 root 2. Got our R. Now, we know that if you wanted to, if you really truly wanted to just play this out, y over x, 3 over -3, we get tan of theta equals -1. Therefore, theta equals tan inverse of -1. And that we know hits on the pi over 4s because pi over 4 had a value of 1 when, for tangent. And we want to be quadrant 2, right? So that would give me a theta value like we were discussing earlier of 3 pi over 4. Now I need to be positive theta. I need to land. So it's r theta and 3 pi over 4. I hope I ordered that other one correctly last time because we know we need r theta order. The r value is 3 root 3. And that'll get us into quadrant 3. I was just thinking too, what if I bounced across or set up my angle? That would be 7 pi over 4. Then I'd have to use a negative r to reflect back. That would be legal, wouldn't it? Because it doesn't say anything about using r as positive or negative. So I got 2 options there. Probably should have had 2 for a too. Convert the rectangular for each coordinate to polar coordinates, keeping in mind that we want theta to be expressed as a positive. So this is rectangular. We're starting with xy. We want to convert it to r theta. To get r, we want to do the square root, don't we? Oh, yeah. Well, let's go ahead and do it. 0 squared plus -2 squared will give me r equal to 4. Square root 4 is an r value of 2. Not a huge surprise. Once I said, oh, I should have been thinking, like, that's just going to plot out right there. And I really don't need a whole lot of help getting myself there, do I? This will be ordered pair of r being 2, which I could have told, right? R is 2 units down, radius of 2. And then I need 3 pi over 2 for an angle. Another option I have is using this spot and reflecting it over. So if I go an angle measure of pi over 2, that would require then this to be -2. You know, maybe we really should have that plus minus going on there so that we think of both scenarios. Probably should have done that on the others. Alrighty, we want to get to xy. I know this is a quadrant 2 value or location. So r plus minus square root 25 plus 144 gets us to a plus or minus 13. Now, angle measure, tan theta equals y over x. And that's one that I don't recognize. So I would get my calculator out and I would do a little tan inverse of 12 over negative 5. And that tan inverse comes out to be a theta. I'm going to look at my notes here. A theta of negative 1.176. However, I cannot have a negative value, so let's just add 2 pi to that amount to swing it into a positive angle expression. And if I add 6.28 to that, I'm going to come in with 5.107. Alrighty, so ordered pair, R was 13, and this will land me at 5.107, which doesn't seem like that is... Oh, that'll land me into quadrant 4, wouldn't it? Yeah, I was thinking that's not going to get me into quadrant 2 like I need it to be, so I'm going to tag on a little negative there. Okay. So negative 13, 5.107. The other option I could have is I want to be over here, don't I, for an angle measure. So this gap we know to be, what was that, 1.176. So I want that gap to be there, 1.176. And if I take negative of that, add with pi, that should get me the sweep for there. Does that make sense? Using a lot of reference angle stuff here. Okay, so we get 13, and I want pi plus negative 1.176. That's got to get me to 1.966, just under 2. So sometimes coming up with those alternative ones can be a little tricky. Just make you think. Use those reference angle ideas that we discuss in pre-calc. Next up, let's convert rectangular equations to polar form. So, x. What do I know about x? Well, I know that x is equal to r cosine of theta. So I'm going to replace x with this. So that's going to mean r cosine theta equals 3. Just like in rectangular, we like y equals. In polar, we like r equals. So let's solve for r. We get 3 divided by cosine of theta. Next one, if you look back, we knew that x squared plus y squared was r squared. And we really can have r being positive or negative. And what does that end up being? Well, we recognize this as a circle, correct? Well, then this is the equation for actually the same circle, but we wrote it in 2 different ways. So either I can hit all the angles in reverse mode, plotting out -4, or I can hit all angles in a positive 4 radius mode. Either way, I'm going to get a circle centered at the origin. The first one, we recognize that as a vertical line at x equals 3. So this is also a vertical line, but written in polar format. All right, now for C, what would be easiest? We got to get it back to r's and thetas. I think substituting x and y's might be our easiest choice. So I'm going to say 3r cosine theta, that's our substitution for x, plus 5r sine theta, that's our y, equals 7. A GCF of r, so let's do r, 3 cosine theta plus 5 sine theta. Remember, as you're doing these, you really just want to get so that you have r on one side, theta on the other. So we're just going to do a cheesy division here and achieve our goal of having r on one side, theta on the others. Not as easy to figure out what that one represents, right? Would be some sort of linear function. You like think about solving that for y. So we can see we got first degrees on both of these. We know this is a linear function. So this too will map out as some sort of line. Okay. How many more we got left? Oh, that was it. Got it. All right, convert the polar equation to rectangular form. This will probably be harder because you won't recognize it quite as much. But this is saying that all r's have all r's are 2, which means the radius is always 2. Theta can be any value, right? Can be not any, but how about every value? So I'm going to have all these radii coming out, right? Because I got to hit every r. And if I do that at a unit of 2 away, that's going to form a circle. Kind of look like a fireworks explosion there. I think I'm going to count by 2s just to make this a little bit larger scale. So there's 2, there's 1. So basically we want to get a circle with a radius of 2, 1, 2. There's -2. That would have been -2. And then draw your very best circle. So this ends up being a circle. And if I wanted to, if I didn't recognize that, I guess what I probably would have done is squared both sides to get it into an r squared format. And then instead of r squared, I'm going to substitute a y squared plus x squared equals r squared idea. So I get x squared plus y squared equals 4. And now we're into rectangular mode. Circle with a radius of 4 centered at 0, 0. Theta equals pi over 6. So this is telling me the angle equals pi over 6. The angle is pi over 6. Well, that's a little hard to map out, but we kind of think of it somewhere along there, right? And it can be any r value. Actually, rather than any, maybe I should say more specifically, every r value. So that I get a set of points, r distance away from that origin, and some negative r's. And if I densely packed it with all the r's that are out there, it would fill in as a line, wouldn't it? So we know this is a line. Now let's try and get the rectangular setup for it. So how, right? I know that tangent of theta is x over y. That would at least introduce, I did it again, it's y over x, opposite over adjacent. That would at least introduce x and y. So you know what we're going to do? We're going to tan both sides. There's our starting point. Now replacing tan theta with y over x, evaluating the tan at pi over 6 is a root 3 over 3. And typical rectangular fashion is y equals, isn't it? So I get y equals root 3 over 3 times x. Linear function with the slope of root 3 over 3. Fantastic. 2 to go. All right, r sine theta equals 3. I know that sine, we could do square root of x squared plus y squared, but we still got to do something with sine. And we know the conversion for sine. Let's start there. We know that sine theta is equivalent to opposite, which is y, right? Because you think of your theta here, vertical movement, horizontal movement, R movement. So opposite over hypotenuse. Let's substitute. R, y over r. Oh, looky there. Don't you love it? R's cancel, and I get y equals 3. Oh, horizontal line, isn't it? Not as easy to pick up when we were looking at the polar form of it, but that is indeed a horizontal line. Height of 3. There we go. Finally, our last one. What might we want to do? Remember, our goal is to get x and y's involved. I'm kind of thinking about squaring both sides. Yeah, maybe. What if I did, let's replace cosine. Cosine adjacent over hypotenuse, so that's an x over r. Oh, I don't even have to square both sides because let's multiply both sides by r. R squared equals 2x. And r squared is x squared plus y squared equals 2x. You know, these just don't come snappity snap for me because I only do them a little bit each year. And it's been almost a full year since I've done them. But, you know, eventually just keep kind of working your substitutions. It's all based on those conversion magic pieces that we had in the very beginning. I'm trying to get back to them. Your little cheat sheet. I mean, this is really the playbook. Should extend it over to this, right? That's our playbook that we have to work with. So keep those handy, see what you can substitute around. And now this isn't quite what I want. I do know that this is a circle. And why do I know that? Well, let's bring things over. It's good practice for you guys. Let's do minus 2x, leave a box, plus y squared equals 0 plus a box. What am I setting myself up for? Little completing the square, right? Complete the square. And then we should be able to get it into a conic type equation. And I guess I kind of left the cat out of the bag when I said it's going to be a circle. Take the middle term, divide it by 2 and square it. That looks like it'd be negative 1 squared. Negative 1 squared is a 1. If I'm adding a 1 to the left side of the equation, then I need to add a 1 to the right side of the equation. Since I completed the square, I created a perfect square trinomial there. So that would be an x minus 1 quantity squared plus y squared equals 1 squared. And now I know the center of my circle is located at 1, 0. And my radius is the square root of 1, right, which is 1. Center of my circle, okay, I'm just going to count by ones on this one, is there. 1 unit away from all of that. Little tiny circle there. All right, that was a quick lesson on doing that. Here's the homework. You should have a worksheet with all the same type of stuff we just processed through. I guess you get an answer sheet too. There should be 2 pages to that, and I'm just not seeing it. All right, good luck. Have fun.